Welcome back to Mr. Greenstein's Geometry. We're talking about section chapter 9.5, and this is part 2. We had just talked about the sine ratio and the cosine ratio, the sine being the opposite over the hypotenuse and the cosine being the adjacent over the hypotenuse. Now let's take a look at this special case of a special right triangle. We know that if we have a 45-45 90-degree triangle, then if this side is 1, this side has to be 1. And to get the hypotenuse, you just multiply the leg times the square root of 2. So it's just the square root of 2. If we just take this as the triangle, if I want to get the ratio sine of 45, I just take the opposite, which is going to be 1, over the square root of 2, which is the hypotenuse. So 1 over the square root of 2. Of course, we don't want to leave that denominator as a radical, so we're going to multiply each, the top and the bottom by the square root of 2, and we end up with the square root of 2 over 2. If you plug in the sine of 45 into your calculator, or you plug in the square root of 2 divided by 2, you're going to get the same number. You're going to get something that's about 0.707. If I take the cosine of 45 degrees, I get this exact same ratio. I get 1 over the square root of 2, which is square root of 2 over 2. And it's the same number, 0.707. For the tangent of 45, it's the opposite over the adjacent. Well, the opposite is 1, and the adjacent is 1. Therefore, the value that you get out of the tangent of 45 is 1. In fact, why don't you just plug that into your calculator and confirm that you get 1 out. Let's look at the other special triangle. In a 30, 60, 90 triangle, I'm going to just concentrate on the 30 degrees, the smaller of the two complementary angles. So with 30 degrees, and I'm using sine of 30, that's going to be opposite over hypotenuse. So if I was to write this, I would get 1 over 2. And if you plug that into your calculator, you should get 0.5, or half. The cosine of 30 is using the adjacent over the hypotenuse. So this time, you're going to have the square root of 3 divided by 2. And you plug that into your calculator, the value that you're going to get is approximately 0.866. You can also plug in the square root of 3 over 2 and check that out. Make sure that comes out the same. The tangent of 30 degrees is opposite over adjacent, so it's going to be 1 over the square root of 3. And of course, I don't like to leave the radical in the denominator, so I multiply the top, the numerator, and the denominator by square root of 3, and I get the square root of 3 over 3. If you work out this number, you plug it into your calculator, you're going to get a number that's close to 0.577. So you can work that out. So those are our special right triangles. Now let's take a look at a real problem, the angle down from the horizontal. If I'm skiing and I'm going on a slope that's about 21 degrees from the horizontal, and believe me, 21 degrees, that's probably a black diamond slope. That is a really, really fast slope. And 21 degrees, and I know that from where I'm starting to where I'm going to finish is about 1,200 feet. That's quite a bit of distance. Then let's calculate what this distance here that I'm actually going to ski. So a way I can do that is I can say, well, here's my angle, 21 degrees. I have the hypotenuse here that I want to find, and I have the opposite side. The opposite side is 1,200 feet. So whenever I think about the opposite, I think of the sine ratio. Let's use that and actually come up with the numbers. We can say that the sine of 21 is equal to the opposite, which is 1200, divided by the hypotenuse, x. If I was to cross multiply, divide each side by sine of 21 and multiply each side by x, I would get x is equal to 1200 divided by the sine of 21. Let me just plug that into my calculator, and I get 1200 divided by the sine of 21, and I get a number of about 3,348.5 feet. So that's how far I'm going to be going down the slope, is 3,348.5 feet. This is called the angle of depression at 21 degrees, the angle of depression. So depression is always based on whatever horizontal line I have and then the angle below that. Let's do a little story to remember all of these different features here, all the different ratios. So how do we remember all of this? Maybe a little story. So we have this Native American, and he is an up-and-coming in the hierarchy of his tribe, and he's a very promising warrior. And he goes down to the creek to do a little bit of studying because he's a very knowledgeable person, and he's going to study about trigonometry. And he gets down there, and oh, he has an accident. He stubs his big toe, and it hurts. It just swells up. So he goes to the creek, and he puts it into the creek, and he lets the cool, cold water run over his foot. And he goes back to the tribe, and he tells them about his problem, and he shows it to the medicine man, and they bandage up his foot. So a little while later, after studying a lot of trigonometry, they decided that they would name him a new name, and he became chief of the tribe. So they called him the name Chief SOHCAHTOA. Chief SOHCAHTOA. The SOHCAHTOA stands for the sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. And that's how we can remember our ratios of tangent, sine, and cosine. And we'll leave that for the next day when we get back together.